Welcome back to Algebra. Today we're going to move on to the next section, 13.4, and the topic we're going to be talking about are what are called inverse trig functions. Now hopefully we'll all remember that over the course of the years we've been talking about all kinds of inverses. We've talked about how different operations are inverses of each other, adding and subtracting are inverses of each other, multiplying and dividing are inverses of each other, powers and roots are inverses of each other. And we've also had functions that have been inverses of each other. As an example, exponential and logarithmic functions were inverses of each other. Well, trig functions also have inverses. Now, the situation in which the inverse functions come up most often is when we're solving triangle problems. Now, the triangle over to the left is a problem that you guys have already done. It's one of those problems where I'd ask you to find the missing pieces, and with the information that's given to you, you would be fine. Remember, the rule was as long as you're given at least three out of the 6 parts of a triangle, and remember what we mean by parts is a triangle has 3 angles and 3 sides, so total of 6. So as long as you're told at least half of those, so at least 3 out of 6, and at least one of the pieces is a side, you can find the missing pieces. Now in geometry next year, we're going to abbreviate the situation that's given over to the left as AAS, meaning we're given 2 angles, the 90-degree angle and the 35-degree angle, and we're given one side. And to solve for the missing pieces, well, angle B is easy, but then to solve for A and B, we can just use basic trig functions, sines and cosines and tangents. But in the triangle over to the right, where we're given 2 sides and 1 angle, next year we'll call that SSA. Just make sure you don't write those letters backwards because we'd have a little cuss going on. All right, but we'd call that an SSA. We have 2 sides and 1 angle. All right, then to find the missing pieces, well, side B wouldn't be so bad, but when we try to find angle A or B, we would have difficulty using our regular trig functions. So what we have to do instead is use what are called inverse trig functions. So let me show you how that's going to work. Okay? When we want to talk about inverse trig functions, the phrase that I want you to remember is this one. When we talk inverse trig functions, this is the phrase I need you to remember. Find the angle whose, and then we have the ... at the end, meaning we're going to fill something in. So we're going to find the angle whose sine is, or find the angle whose cosine is, or find the angle whose tangent is, and then we'll have something that follows. Okay? And so the notation that we're going to use, and I forgot to write the word notation in here, sorry about that, guys. So the notation that we're going to use is any of our trig functions, so sine, cosine, tangent, cosecant, secant, cotangent, any of our 6 trig functions with the little -1 superscript attached. So we have a -1 superscript, a -1 superscript, a -1 superscript. Those little -1 superscripts mean we're taking the inverse of whatever it's attached to. All right? So if I use my laser pointer here, this -1 superscript means we're going to be taking the inverse sine. Over here, the -1 means inverse cosine. This fellow over here means inverse tangent. And then what I've done is I've taken a picture of my calculator so you can see where those functions are located. Here's your main sine key, cosine key, tangent key that we've been working with off and on for the last couple of sections. But now notice up above, up on the plastic housing of your calculator, we have sine with the -1 superscript. So that's going to be inverse sine. Above the cosine, cosine with a little -1 attached, that's inverse cosine. Tangent, and then tangent with a little -1 attached, that's inverse tangent. Okay, so just so you know where they're located. And because the inverse trig functions aren't the main function on your calculator. They're what's called a secondary function. What we're going to have to use to get to those functions is the second key. But we'll talk more about that as we go along. Okay? But again, the key phrase I want you to start with in your head, anytime we see a inverse trig function, have the phrase in your head, find the angle whose, and now I'll show you how we're going to finish those off. So here's some examples of problems that I'm going to ask you to do without a calculator. Okay? Don't touch your calculator yet. What I'm going to ask you to do here is evaluate these inverse trig functions. All right, so as an example, the first one, in fact, if you want me to, I could number these fellas. So in fact, let me just get that over with so you know exactly which one I'm on here. So 1, 2, 3, 4, 5, 6, and then number these two fellas at the bottom, 8 and 9. Okay, so number 1 says inverse sine of 1/2. Now, all by itself, you'd be thinking, what in the world? I don't know what that means. But again, please consider the phrase. The phrase I want you to have in your head is, find the angle whose. All right, so now if we fill that in for my number 1, it would be find the angle whose sine value is 1/2. Right, so that would be the completion of the phrase. Let me do it again. Find the angle whose sine value is 1/2. Now, to do this without a calculator, what I need you to do is go back into your notebook to the table of values we developed a couple of days ago for all of the trig functions involving 30, 45, and 60 degrees. And then the other table with our quadrantal angles, so all of the trig functions for 90, 180, 270, and I forgot how we wrote it, if we wrote it as 360 or 0, it doesn't matter, right? Look up those tables. If you need to pause the video, go back in your notebook and put a pencil or a piece of paper into the pages by those tables. All right, now the problem, find the angle whose sine value is 1/2. What I need you to do is go to the table. Underneath the sine, go down until you find 1/2. Once you find the 1/2, scoot yourself over to the left, and what angle do you bump into? The answer is 30 degrees. Right? Go down the sine column until you hit 1/2, and then go across to the angle, and you'll see 30 degrees. Okay, we can do that a couple more times. Number 2, the inverse cosine of the square root of 2/2. Put it together with the phrase, and it becomes, find the angle whose cosine is the square root of 2/2. So again, you go to the table. This time you go under the cosine until you get to the square root of 2/2. When you get to the square root of 2/2, go across to the angle, and you'll find the angle is 45 degrees. Right? The inverse tangent of the square root of 3, what that tells you to do is find the angle whose tangent is the square root of 3. So this time we go under the tangent column until we get to the square root of 3, go across to the angle, and you'll find 60 degrees. My number 4 is a little bit harder because the inverse sine of 1 is not in that first chart. It's not in the chart that for the 30 degree, 45 degree, and 60 degree angles. This one's going to be located in the chart with 0 degrees, 90 degrees, 180 degrees, 270 degrees. But the idea is the same. Go underneath the sine column until you get to a 1. Go across to the angle. And what angle do you find? 90 degrees. Okay, try a couple more. How about the inverse cotangent of the square root of 3/3? The idea, go back to your first chart, go under the cotangent column until you get to the square root of 3/3. Go over to the left to see what the angle is. In that case, the angle would be 60 degrees. And one last one here to start with. What's the inverse cosecant of 2? Now put that together with the phrase, find the angle whose cosecant is 2. So you go underneath the cosecant until you find the 2, then go across to the angle, and the angle you'll find is 30 degrees. Okay? Alrighty, so I'm going to scroll this down so you can see these. I'm going to need just the tiniest bit more work here. Tiniest bit more room here for my number 7 and number 8. Now the problem for number 7 says find the inverse sine of negative square root of 3 over 2. Now if I could change my laser pointer to being a hand. All right, and get rid of that fella. Okay, so now if I could, if we were all together in class, I'd shine this one up on the screen, and then I'd use my hand to cover up the negative. And I'd ask you guys, can you tell me what the inverse sine of the square root of 3 over 2 is? The idea would be, you go underneath the sine column until you find the square root of 3 over 2, and then you go across to the left to see what the angle is. So if you guys would do that, without worrying about the negative that's there, just pretend it's not there for a second. What angle would give us a sine value that's a square root of 3 over 2? Let me do it one more time. Find the angle whose sine is the square root of 3 over 2. And what angle do you see? It should be 60 degrees. But unfortunately, now I've got to move the little hand thing out of the way. There actually is a negative there. So how do we account for the negative? Well, what we need to remember is what quadrants, in what quadrants is the sign positive and in what quadrants is the sign negative. And hopefully you'll remember from a couple of days ago we had a chart that said the sign is positive in quadrant 1, positive in quadrant 2, negative in quadrant 3, and negative in quadrant 4. Now I'm only writing out S for the sign. Of course, what's in your notebook has all of the trig functions, but that's just the values for sine in the different quadrants. Okay? So what I'm asking for is find the angle whose sine value is negative square root of 3 over 2. So what we have to do is we have to pick one of the quadrants where the sign is negative. So we have to pick either quadrant number 3 or quadrant number 4. In other words, what we do is we pitch quadrant 1 and quadrant 2 into the garbage. And then do you remember what the angle was when we pretended the negative wasn't there? The angle was 60 degrees. And so what we're going to do, guys, is we're going to draw in a 60-degree reference angle in quadrant 3 or a 60-degree reference angle in 4. And then the answer to your problem is either going to be the standard position angle in quadrant 3, or if I change colors so that you guys can see the difference, I think green will show up pretty well, or the standard position angle for the 60-degree reference angle in 4. Okay, and can you guys get those? As an example, what would the quadrant 3 one be? Well, it's going to be 180 degrees plus 60 more, so the angle would be 240. But if somebody else, if Rachel would have said, I don't want to go in quadrant 3, I want to go in quadrant 4, what would be the standard position angle for a 60-degree reference in 4? The angle would be 300. In other words, here what you'd actually have is a choice. Now, you don't need to give me both. You don't need to give me both. You just need to make a choice and pick one or the other. Okay? Now, similarly on my number 8, finding the inverse secant of negative square root of 2, what we're going to do is pretend, I'll choose my little hand icon here, we're going to pretend that the negative isn't there to start with. We're going to pretend it's not there, and I'm going to ask you to find the angle whose secant is the square root of 2. So when you go under secant in your table, in your chart, down to the square root of 2, and then across to the angle, what angle do you find? 45 degrees. That's the angle, right? You find in your chart. But I actually have to get the little hand icon out of there. And now to answer the question, where is that going to be negative? So again, what we have to do is go to our chart and ask ourselves, where's the secant negative? And from your chart, you see that the secant is negative in quadrant number 2 and in quadrant number 4. So you're going to have a choice of either drawing in the 45-degree reference angle in 2 or the 45-degree reference angle in 4. And then what I'm going to need from you guys is the standard position angle in 2, or I'll do it in green again, all the way around to 4. And so again, we're going to have 2 possible answers. The 45-degree reference angle in 2 would give us an angle of 135 in standard position. And in quadrant 4, it's going to be 315. Again, choice. You don't have to give me both. Now, with that logic, with what we just talked through with, hey, you know what? The sign is negative in 2 different places. The secant is negative in 2 different places. What we actually could do now is we could go back to some of our original problems and we could get an alternate answer. We could get an alternate answer to this first one as an example. Because the question started off, find the angle whose sine value is 1/2. And I just had you look in your table. I had you go under the sine column until you bumped into 1/2, go over to the left, the angle's 30 degrees. But because the 1/2 is positive, I could ask you, find both quadrants where the sign is positive, obviously in quadrant number 1, but the sign is also positive in quadrant number 2. So we're going to again have 2 possible answers, the 30-degree reference angle in 1 or the 30-degree reference in 2. Okay? Now, like we've said earlier, when we're in quadrant number 1, the reference angle and the standard position angle are the same. But if we're in quadrant number 2, the standard position angle would then be 150. And the same would be true for almost all of the first 6 problems. Number 4 is an exception. But 1, 2, 3, 5, 6 would all have 2 different places that the sine would be 1/2. Cosine would be the square root of 2/2. The tangent would be the square root of 3, and so on. But again, I'm only going to require you guys to get one of the 2. When there's 2 options, I'm only going to ask you for one of them. Okay? Now, I also need you to be able to do this with your calculators. All right? So now I need you to get your calculator out, and we're going to find angles whose cosine is 0.26 as an example. Okay? Now, first of all, we can either give our answers in degrees or radians, but just to make sure we're all on the same page. So everybody who's taking notes as we go, take a couple of seconds and make sure your calculator is in degree mode. Make sure it's in degrees. Okay, hopefully with that done, and if it takes you a little while, pause the video. But then can you tell me what the inverse cosine of 0.26 is? All right, well, what we're going to have to do is access the function on your calculator for inverse cosine. So what we're going to have to do is start by hitting the second button. So everybody who has a Texas Instrument, start by hitting the second button and then hit cosine. And what you should see on your window is cosine to the negative first. Cosine with a -1 superscript. And then what we'll do is we'll input 0.26 and hit the equal sign or the enter. And what we should all get then, the inverse cosine of 0.26, it's only going to give us one of the answers, and I'm going to round everything to the nearest tenth. It's going to give us an angle then of 74.9 degrees. If you got something else, double check to make sure you're measuring in degrees. And now we can just bop through a few more of these. The tangent of 1.84 is, excuse me, let's see. Oh, I hit the wrong button there. There we go, guys. 1.84 is about 61.5 degrees. The inverse sine of 0.17 is about 9.8 degrees. And notice now my next examples, like the fourth one, is the inverse sine of a negative value. That's okay, your calculator can handle that. So negative 0.37 gives us an angle of negative 21.7 degrees. Remember, the negative just means we moved clockwise instead of counterclockwise. Now, this example that I'm going to box in is one that everybody's calculator is going to give you an error. Right, go ahead and try it. The inverse cosine of 4.2, not negative, but just 4.2. Everybody's calculator says error. All right, and that means that you can't find the inverse of every possible value, right? You can't find an inverse trig function for every possible value. So 4.2 is an example of something we can't take the inverse cosine of, and that's okay. That's okay. And then the sixth one here is kind of tricky because I'm asking you for the inverse cosecant of 2.3. Well, nobody has a cosecant button on their calculator, so how in the world can I expect you to find the inverse cosecant? And the answer is, what I need to do is I need to think of cosecant as being its reciprocal function. What's the reciprocal again of cosecant, guys? I hope you remember that. That's sine. So this is equivalent to taking the inverse sine of 1.23. In other words, what I'm doing is taking the reciprocal of cosecant and the reciprocal of 2.3. So the inverse cosecant of 2.3 is the same as, equal to, the inverse sine of 1 over 2.3. And everybody has the inverse sine button on their calculator. So you just have to take the inverse sine, and I just hit a wrong button there. There we go. Now I'm in good shape. You take the inverse sine of 1 over 2.3, and it should get us an angle of about 25.8 degrees. Okay? All right. And then I'm going to help you guys out with a couple problems from the book, because there's a couple problems that always mess students up every year. They're good ones, but I want to be able to give you a little bit of help. So I'm going to do numbers 20 and 22 from your assignment. Okay? And what they ask you to do in this group is, let me read the directions for you. Use a calculator. Whoop, no, I'm on the wrong one. Solve the equation for theta. So what it's asking you to do is find the angle. Let me draw a big arrow in here. So it's asking you to find the angle theta. But remember what we've been doing all day long here today. The directions have been find the angle whose, all right? And so that's exactly what we're really doing here, is we're finding the angle theta that has a cosine value of negative 0.82. Now, since this is a crazy decimal, you know it's not on any one of your charts, so it's going to be a calculator problem. But then the question is, what does this do for us? What is the idea that theta has to be between 180 degrees and 270 degrees? What's that really doing for us, guys? What that's telling me is, since 180 degrees is to the left, 270 degrees is straight down, what that's telling me is we're looking for an angle in quadrant 3. So this is just equivalent to saying, let's look in quadrant 3. So what I need you to do is use your calculator and take the inverse cosine of 0.82, not negative 0.82. Forget about the negative for a second. I'm trying to use my hand icon. Don't worry about the negative. Just take the inverse cosine of 0.82. And when we forget about the negative and just take the inverse cosine of 0.82, what we get as a result is 34.9 degrees. That's an angle that's obviously not in between 180 and 270. So what we're going to do is sketch that in as a reference angle. And now what I want, I'll switch to green so it's more obvious. Now what I want is the standard position angle from the positive half of the x-axis all the way around. So that's going to be straight up is 90, to the left is 180, and I want to go 34.9 more. So that's going to get me then 214.9. And in fact, let me just write it in green so it's obvious. So theta is going to be 214.9 degrees. Okay? Please notice that that angle is in between 180 and 270. Okay? Let me scooch over the screen just a hair. Now we'll do this next one. If I tell you the sine of theta is 0.15 and I ask you to find an angle between 90 and 180, can you guys get that done? All right? Again, the question is find the angle whose, so of course we're going to be using an inverse trig function. But what this thing at the end tells us, 90 degrees less than or equal to theta less than or equal to 180, just tells us that we're going to be looking in quadrant number 2. Remember, straight up is 90, to the left is 180, so we're looking in quadrant 2. So we tell our calculator to find the angle whose sine value is 0.15. And what we get is an angle of 8.6 degrees. So when we punch this out, we get 8.6 degrees. But obviously that's not in between 90 and 180. So what we do is we sketch that in as a reference angle. So the 8.6 is going to be a reference angle, and then the angle we want is the standard position angle. And what would that be? In this case, that's going to be 180 minus 8.6, which is going to get us an angle of 171.4. Okay? All righty. I know this one's going a little bit long, but we're almost done. We're almost done. All right, so just a couple more quick problems. Sorry this one's going a little bit too long. All right, so here's finally one of the triangles that I started you off with, where I'm telling you two sides and one angle. I'm telling you the side 17, the side 6, and angle C is 90 degrees, so two sides and an angle, and I want you to find the missing pieces. Okay? So as an example, to start with angle A, if I wanted to find angle A as an example, what I would do, and I'm just going to circle that so you have it highlighted, what I'm going to ask you to do is label the sides. All right, directly across from the 90-degree angle is the hypotenuse. Directly across from the angle that I circled is the opposite, and that leaves this side to be the adjacent. So what I'm going to ask you to do is pick the trig function that involves the two sides that I know. I know the opposite and I know the hypotenuse. Opposite, hypotenuse leads you to using what trig function? The sine. But the sine of what? We don't know the measure. We know it's A. We don't know how many degrees big it is. But what's sine equal to? Sine is equal to the opposite side divided by the hypotenuse. So just as we had on our previous problems, what we're really doing is asking, find the angle whose sine value is 6/17. And so what we're going to do technically is we're going to take the inverse sine of both sides. So that on the left-hand side, the inverse sine and the sine cancel. And on the right-hand side, we have the inverse sine of 6/17. And our calculator does that. Inverse sine of 6/17 equals, and what we get is approximately 20.7 degrees. So we have our angle A. Right? We have our angle A. And now that we know angle A, now we can do the subtraction method to get to B. Meaning, remember that the three angles inside of a triangle always add up to 90, or knucklehead. They always add up to 180 degrees. So if angle C is 90 degrees and angle A is 20.7 degrees, that means angle B then has to be the subtraction. So it's got to be 180 minus 90 minus 20.7, which leaves us with 69.3 degrees. And then finally, the third thing we're missing is the third side. And you have two ways to get to the third side, little b. You could use trig, so you could use sine, cosine, tangent, one of those, or you could just do Pythagorean theorem. All right, so you could just go back to the last couple of years. Pythagorean theorem would be 6 squared plus b squared is equal to 17 squared. 6 squared is 36. 17 squared is 289. So when I move 36 to the other side, I get 253. And then to get rid of the power of 2, we just take the square root of both sides. So b then is going to be the square root of 253, which is approximately 15.9. Okay, and we have our three missing pieces. All right. Now, since this one's going so long, I'm just going to skip the next problem. It's really just the same as the previous. And just make one mention, because I think when I set up the schedule, I think I may have messed this one up. Because we're not all together, number 38 is really going to be a tough one. So feel free to skip number 38. If you want to do it just for fun, that's fine. But otherwise, that's a tough one if we're not together where I can explain that one to you. So feel free to skip it if you wish. Okay? But otherwise, you should be able to stop this video and then work through the problems in section 4. Hope this finds everybody doing well, and I hope to see you guys soon. Have a good day. Bye.